A UVM sequence class. A UVM sequence is a place where you will actually create transactions and send them to the sequencer and to the driver. So this is the general structure of the sequence class. Class your own sequence name will extend from the UVM sequence, and also in the sequence you will give the type of transaction which is dealing with. So the UVM sequence class also should parameterize with the type of transaction it is dealing. So here it is sending the AXI transaction type sequence items. Thus it is parameterized with the AXI transaction class. And the second line is the factory registration macro. Again, as this the sequence item class and the sequence class are data classes which is directly inherited from the base class. We will be using the tick object util macro to register this class with the factory. And also the new function have only one argument, and it doesn't have the parent argument. There is a virtual task called body in the UVM sequence. This is a place where you will actually create transactions and send them to the sequencer. So you will be always calling a sequence.start in a sequencer. Typically this is done in a test. So whenever you call the sequence.start with the sequencer handle, this body function of that particular sequence will be called. So this is the function that is getting called whenever you are calling the start sequence.start function in the test. So that will eventually create transactions and send them to the sequencer. So this is the general structure. Maybe in a repeated loop you can create a number of transactions, and for every transaction you should create the object, and you should put like start item of this transaction. So this will make sure that the driver is ready to accept the next transaction, and after that, if you want, you can randomize the individual members of the transaction using transaction.randomize. And again you can put an assert statement if it is failing or not. And once you've done with the transaction handling or transaction making, you can actually send them to the sequencer by using the finish item method. So finish item of transaction will send the transaction to the sequencer and eventually to the driver. And if you want to get a response from the DUT, you can wait for a response from the DUT by calling a get response function. So which will again wait for the response that is driven from the DUT, which will be sent from the driver class. Again, this is optional. If there is no need to wait for a response from the driver before sending the next transaction, you can just repeat this creation and sending of transaction in a loop as many times as you want. So again, this is general outline of a simple sequence. There could be other complex logic added here based on the behavior of the DUT and the driver. But remember that your sequence and the driver should always behave in hand, so that if a sequence is expecting a response from the driver should send the response, and then only the sequence should send the next transaction. So you should always keep in mind the behavior of the driver when you actually write the implementation of the sequence. Now you have gone through the implementation details of all the classes in the UVM structure, right from the UVM topmost test bench module, UVM test, UVM environment, UVM agent, UVM scoreboard, UVM driver, monitor and sequencer. Again in the data part you had learned how to write a UVM transaction and a UVM sequence. So you might not be able to connect them together at this point, or you won't be able to understand all the details here. And in the next session we'll be dealing how the connection is made between these two components and data is flowing from one component to another. After going to the next session also, if you revisit the same session, these concepts will be more clear for you.